My name is Keith Hare, and I've done a little bit of work with the GQL standard over the last couple of months. And I want to talk a bit about what's going to be in the next version of the standard and what the timing might be. So, who am I? I'm a database geek. What do we?
Oh yes, yeah, it's the Zoom gods. We just need to go to Zoom, share, and that should be good. And it should be good even when we start the slides again. Is it good, Henry?
Yes.
On Zoom, perfect, thanks.
Okay, so I'm a database geek and have been for a while. As a consultant, my specialty has been high performance database systems in an obscure niche. I've done a lot with data replication and data migration and database administration. At some point, I got involved in the SQL standards, and because of an inability to say no, I've ended up as the convener of ISO, IEC, JTC1, SA32WG3 database languages. There'll be a quiz on that later. And the vice chair of the US committee, Insights Data Management. I've also, for a number of years, been working on a contract with Neo4j where I was actually getting paid to help develop the SQL standard, to do standards diplomacy and GQL strategy and things like that. So I'm a database geek, I'm a standards geek, and I've become a GQL geek. Database standards, the SQL standard has been around for quite a while. The initial version of the SQL standard was published by ISO in 1987. And is now up to 16 or to 11 parts, including part 16, which is property graph queries in SQL. The GQL standard was published in April of 2024, April 12th, if you were paying attention as I was. What we're working on now is the next editions of both SQL and GQL. I'm going to focus on GQL. We have a number of things that have already been accepted, and I'll talk a little bit about that. Stefan sort of waved at conditional procedures. I'll spend a little more time on vector data types and vector queries. Those have been accepted. We have some papers for upcoming meetings on things like list element references, constraints and keys that Stefan talked about, call per, sum and product, which is a little obscure, but it actually is foundational work for cheapest path work. We have some corrections and bug fixes because we didn't get everything right the first time. And I'll wave at some things that might also happen and then talk about the timing. Conditional procedures. Stefan mentioned this. It's the idea of being able to say that if this condition holds, then do this, otherwise do that. And actually control the data flow in the term we use is a GQL program, but basically a statement. And we can talk more about that offline. I want to spend a little more time on vector data types. Recently, there's been sort of a lot of discussion of something called AI, whatever that happens to mean. And some focusing on actually integrating some of the AI techniques with existing data. And the acronym is Retrieval Augmented Generation. So strangely enough, people have interest in adding this to the standards. So last fall, Oracle came in with a proposal to add a vector type to the SQL standard, and that was accepted by the committee. And then we essentially adapted that proposal for GQL. So we've added in the draft, we have a vector data type. And as a separate step, this was all in one paper for SQL, but it took 2 papers for GQL. We added support for something called limit approximate. And we'll come back to that because there's some interesting implications of that. So if you're around this, the basic vector data flow is you have some sort of unstructured data, text or photos or whatever that might be in the database, might not be, but you somehow want to integrate that with existing data, properties, nodes, edges, whatever. And so what you do is you generate a vector embedding. Okay, that's outside of the database because there's gazillions of vector embedding generation routines, and that's never going to be standardized. What we want to be able to do then is to store vector embeddings in the data, in the GQL data, essentially as a property in a node or an edge. And then we want to be able to query them. Now, there's this magic called indices, which the standard doesn't mention, but you really need for performance. And so the way this is written is it allows for indices, but doesn't actually mention them by name. So we're going to look at storing vector embeddings and querying them. So the data type, it's an atomic data type, but it sort of has 3 components, a vector of values, and we'll support whatever an implementation supports, information about the type of the vector values and a count of the values. And from a GQL point of view, that's a single piece of data. So we don't offer any way to look at the elements of the vector. It's the whole thing and nothing else. You store those as properties. Add it with an insert statement. So I'm going to insert a node, and I'm going to, in this case, it's a vector, and I've got this square bracket with dots between it, which is magic happens here that's outside of the control of the standard. How you get that vector, what exactly it looks like, is going to be product defined. Not something we define in the standard. In this case, it's got a cardinality of 128 and it's a float 32. Whether that or not that's a reasonable vector, I don't know. Doesn't matter for this example. But what we want to be able to do is to do queries where we find how alike some vector is with everything in the data. And so what we're going to do is to use a vector distance function that compares 2 vectors for a particular distance metric and returns a value that is a relative distance. Now, one of the things about the way this is defined in GQL and SQL is that with a vector distance function, the smaller the return, the smaller the value returned, the closer, the more alike they are, the vectors are. And other things use, talk about similarity functions, where the larger the value, the more similar they are. But what we're going to want to do with this a lot is to do an order by the values so we can find the 10 that are most similar, and order by an SQL and GQL defaults to ascending. So the way vector distance is defined, I just do an ascending sort. With the vector similarity stuff, you have to explicitly say sort descending to find the closest things. And so that's one of the difference between what we've done in the standard and other products. And I think we're making the right decision. The algorithms, there's a bunch of algorithms, and you can go off and look up how these are calculated. And I'll leave that for an exercise afterwards. But basically, I want to do something like I want to match some sort of article and go find other things that are similar. In this case, it's going to return at most 10 results. But one of the things about vectors is that the vector index techniques, algorithms, tend to be things like approximate nearest neighbor. With a standard B-tree index, you read down the index and you get things in a particular order, and it will exactly match whatever your predicate is. With a vector query, it gets funky. And so what we've done is we've added this keyword approximate, and it's a little obscure, but if you look at the rules, what that does is it gives the implementation the right to return things that approximately match what your query is. So by using the vector index, you'll get data quickly. It might not be as an exact match as if you had said part color is equal to red. So that's sort of an obscure thing that is going into the standard and allows for implementations to use vector indices. How do you create vectors? There's thousands or hundreds of thousands of vectorization functions, and they're specialized by data type. So you might have to choose from 10 different vectorization functions for particular types of photos. And so there's no way we're ever going to be able to standardize that. So that's left up to the implementation and to the environment. And as I said, indices are outside of the standard. They have some additional operators, constructor function, a vector construction function, something returns the dimension count, the vector norm, which is the distance between a vector and zero, vector serialized, which allows you to return a vector as a character string. Database vendors are adding capabilities to products now. So, for example, Oracle 23 AI has a lot of this vector stuff in 23 AI and released product. My claim is that the vector capabilities are valuable enough in the standard to justify new additions without any additional work. And I'll come back to that when we look at the timetable. What else is there? List enhancements. One of the things that we didn't do in GQL version 1 was to include the ability to access an element of a list. Why? Because the property graph people have tended to think in terms of zero-based arrays or lists, and the SQL people have tended to think in terms of one-based. And for GQL version 1, if there were stuff where we couldn't come up with a compromise, we kicked it down the road. And so this looks like a simple thing, but what we're proposing is actually a compromise, and it's accompanied by the ability in a session to say what the list behavior is. And the characteristics are whether you're doing a zero-based or one-based. What happens if a negative? Do you do an error, or do you calculate from the end backwards? And what happens if you're out of range? Do you do null, or do you do an exception? So this is something that looks simple, but actually there's a fair amount of compromise here. And actually some of this capability may end up getting proposed for SQL at some point, because it turns out that SQL people also want to be able to say, hey, if I access something out of range, I want to null. I don't want to blow up my 30-minute query. I want to get a null and continue. Constraints and keys, Stefan mentioned, and he can talk to you a lot more about that. We have a discussion paper submitted for Barcelona, and that I think can be turned into an actual change proposal. partitioned call operator, call per. Stefan also mentioned, and we'll be talking about that at the WG3 meeting in Barcelona in 2 weeks. Sum and product. Sum already exists, so it's an aggregation function. The thing about sum as it's currently defined is that if you have an empty set or a set that's all null, you get a null. It turns out that when you're beginning to look at cheapest path calculations, there are times when you want to be able to say that I want the sum to return a 0, not a null. And that's actually generally useful in other things. There's a new aggregation function product that basically multiplies everything. And the same thing, I want to be able to control, sometimes I want a null, and sometimes, for example, the cheapest path, I'm going to want a 1. And so this is another proposal for Barcelona. There's some bug fixes, and we'll be publishing a technical core agenda, which is a fancy name for this is what we got wrong in our fixing. Anything else? I mean, mentioned optimal or cheapest path. That's likely to happen. Schema information graph. Is there anything else? I can list 10 years worth of work to do on the GQL standard. And I suspect Stefan can list 10 years worth of work, and it's probably not exactly the same list. So yes, but we need to get something done. And so I'm claiming that the capabilities that we've already accepted or are discussing this month are enough to justify publishing GQL version 2. And there's a sequence of steps. We're going to start what's called a committee draft consultation at the beginning of November. It's a 12-week process. We send it out to a bunch of people. They comment. We then resolve the comments. How long will it take? Depends on how many comments. For GQL1, for the CD consultation, we had 700 comments. It took a little bit of work to resolve them. I suspect we won't get as many for GQL version 2, but we'll get some. The next step is what's called a draft international standard, a ballot. And that actually takes 20 weeks. The first 8 weeks are we send it to the ISO Central Secretariat, they twiddle their thumbs, and they start the actual ballot. We have 12 weeks to write comments. So my best guess at the moment is that by November of 2026, we can start the DIS ballot. If we satisfactorily resolve all of the CD comments by, say, June of 2026, we could start this process earlier. If we stick to this timetable, we'll have a document ready for publication mid-2027. And I'm sort of motivated, so I will push to not let anything derail this. And SQL is on a similar timetable. So we published a standard. It's a pretty darn good standard, I think, but it doesn't have everything. Has bugs, doesn't have everything in it that's useful. There's more things that are useful, particularly support for AI capabilities. So we have a number of things that are either accepted or we have concrete proposals that we'll look at in a couple of weeks. There may be other new things. Any questions?